Oh my god, what if this becomes my biggest failure? I'm attempting the 100k build challenge. No team, no outsourcing, just me and AI tools working together. If you want to watch someone actually build something without the BS or staged content, you're in the right place. It's Memorial Day weekend, and whilst everyone is relaxing, I'm seizing this moment to get my product to as many eyeballs as possible. Again, this is the AI build challenge. The rules are the same. Build in public, document everything, only use AI tools, and hit 100k or die trying. So if you're new here, previously we integrated a baby podcast. If you're not familiar with the viral baby podcast, it's a baby talking head that talks about really serious subjects, and we integrated that into our application. And basically you give it a topic, you select your baby preferences, Black, Asian, Middle Eastern, and it's going to generate a baby podcast based on that topic. I'm at a point now where I feel like we are at an MVP space where we have a working prototype and we need to get it out there ASAP. So we used ChatGPT 4o image generation model to be able to generate baby images based on the specifications provided. And then we also use ChatGPT 4 to generate a script that would be read later by ElevenLabs. And ElevenLabs is just an audio generation platform that can clone your voice or turn text or script into speech. And then we tied both the audio that was generated by ElevenLabs and the image that was generated by OpenAI, and sent these files over to Hedra to use the audio and the image, and then produce a video of a baby actually talking with their lips actually syncing with the audio. So that is what we've been able to achieve. So initially I was storing all generated content, images, audios, videos directly in the application directory. This seemed fine during development, but once I decided I needed to launch the application, I quickly realized this was going to be a scaling nightmare waiting to happen. The solution was a cloud storage comparison. I evaluated two main options for cloud storage. One was Supabase storage, and for one, it just easily integrated with the existing Supabase setup. Supabase is also good for rapid prototyping and smaller applications. That made me realize it wasn't fit for what I needed. So I researched one other option, which is Amazon S3, which stands for Simple Storage Service. For one, it has industry standard reliability, but it was more complex to set up. Fun fact, Supabase is actually built on top of S3, so Supabase is essentially would be a middleware. So this is how you create an S3 bucket so you can access it from your application. First of all, go to AWS Management Console, and once you are there, go to Products and scroll the way down to Storage, and you're going to see Amazon Simple Storage S3. Click on that and create an account, and this is going to take you through the account creation flow. And once you create an account, you get this congratulations page. Click on the S3 in the page after the congratulations page, and then create a bucket. Okay, once you click create a bucket, it will ask you for the bucket name. Just enter the name you want to give to your bucket. In this case, it's content desk, and then create bucket, and you can click on the bucket you just created. You can upload files here. You can add some additional folders here if you want to. Okay, so the next thing you want to do is to create an IAM account or IAM access. You need to create an IAM access. So go to the menu at the top and click on IAM, and once you land on this page, it should give you an opportunity to manage access keys if you already have them set up. If you don't, just click on the manage access keys, and that should take you to this page. And if you go down a bit, you see access keys right there in the middle. Okay, you can click on create access key and just acknowledge that you understand. Just acknowledge that and create access key, and that should present you with your access key and secret access key, and from here you can copy those. So if we come to the generate video route, so API generate video, and so if we go to the application and go to generate content and go to the page, character form, go to the page. Right here is submitting, and if we go on top of the form, should be form here, handle submit. So if we go all the way to the top, handle submit, go to the content generator process job, and this is what processes the generation of the video. So if we come here, process job, to the route, just gonna scroll all the way to the top here, and we connecting to the database, retrieving all of the relevant data, we fetching, generating the script, generating the image, generating audio, and I'm just looking for an API. Generate video right here is where we are calling the generate video endpoint, and we are sending the image URL, the audio URL, the character type, and the topic. So over here, generate video is being called from right here in Hedra. So Hedra is where we are actually making the API request to basically go out there and take the audio and the image and merge them together and sync them and generate a video. So that is essentially what we're doing. And so we get the video back from Hedra. We want to upload it to our S3 bucket. This is where we make that happen. So if you remember from Hedra, what we're doing before was we wait for Hedra job completion, and once that was completed, we store the video buffer inside of the local publics directory. So right here, videos, we essentially stored all of the generated videos here, but we don't want to do that. We want to upload it to S3 instead. So what we are doing is, first we download the video from the URL that is provided. So we get a video URL from Hedra, and then we download the video right here, get the video response, and we are basically defining these values here. File name, we just creating a file name with the current date and the character type, .mp4, S3 key, and then constructing the S3 key. The S3 key is essentially the folder we are going to be storing this data in S3 bucket URL video / the file name that we created up here, and then the video buffer, we just passing this over to the buffer class, and we passing the video response data to it, and then we pass the video buffer, the S3 key, and then this is the video type, video / mp4, and we are passing that over to the upload buffer to S3. So if we come over here to upload buffer to S3, we are essentially checking the key that we got back from here. So if we go back, the key, how did we construct it, video / the file name. So we basically checking to make sure video starts with video /, and if it doesn't, if it does start, we use the key we get back, and if it doesn't, we reconstruct it again. This is just to make it a little bit dynamic, just in case we are passing just the key with that constructing this. So that is what this is for. And then we are defining this params variable here and defining the bucket. These are all data we need to send over to S3. So buffer, and then we passing on the buffer name, which is right here. So actually, let me go up here. So we install AWS SDK /client /S3. So you make sure you yarn or npm install that. So if we go into our package.json, we should have that already installed. So we have this version is currently installed. So you need these two packages to be installed in your package.json for this to work properly. So we install it and we import in the S3 client and these utility functions as well, put object command, which we will be reviewing in a second, but this is the important part we should be looking at right now, S3 client. And what the S3 client allows us to do is initialize S3 by passing our access key ID, and then define your AWS access key ID and AWS secret access key, and all of these are defined in our .env environment. Somewhere I'm going to show you how to retrieve these keys so you can essentially pass them down here. And if you don't know how to retrieve them, or if I messed that part, just go to Perplexity and ask how to retrieve the access key ID and AWS secret access key, and just set them up in your .env file and you should be able to pass them here. So we should be able to send these over to the credentials, and for the region we are sending it to the US East too. So these are very important, or else there's no connection that is going to happen for us to be able to connect to the, what do you call it, the proper S3 setup that we did to be able to connect properly to the S3 bucket that we created earlier. So over here we just defined the bucket name, and I did the same thing, just assigning the bucket name I created earlier in the .env file, and basically assigning it to the bucket name and passing it along to this param, and then passing the key, full key that we reconstructed here, just passing it to the key. The body, we passing the buffer that we are getting from the upload to S3. If you remember Hedra, we are passing the video buffer. So that is the video itself that we are passing on to the body, and then there is the content type we defined right here. So that is basically what we are passing, and then we are passing this param over here. We're just doing a little bit of debugging. So in this try catch, we are calling the S3 client again after initializing, and the connection is made. We are basically calling the S3 client that the send method, and then we are creating a new put object command, which remember we imported from AWS SDK package, and then we are passing the params into it, and then we await this API call. So this is going to take a few minutes or a few seconds to upload, and once that is done, we console log this that, oh, it was successful, and then we get the URL back, and we just define this utility function here, get S3 URL, which is right here, and it basically cleans up the URL a bit. Assign bro, which is also from the S3 package, so we just clean it up a bit. Same from the S3 bucket, and then we are passing the URL back to whatever I was calling it, which was Hedra. So we call the upload buffer to S3, so we get the URL, which is what we are passing on to this variable. So we grab that variable, right? We create a cache, and we return the URL here. So once we return that URL, we have the video downloaded to our S3. We now have the URL to the video, and then we can display in the front end. So that is essentially what that is doing. So over here, video URL, you remember video URL, we are getting that video back, and we eventually store that data, video URL, to our database, so we can always retrieve that later. And later on, you're going to see we will display all of the videos that has been generated by the user in their history. So we will retrieve all of the URLs from the Supabase database, and essentially we're just storing the URL to the database. Actual video itself, the content, is an S3, but it's just providing us a public URL that you can use to actually get access and watch the video. So that is what is happening here. So that is the setup. Hopefully that makes sense, and if it doesn't make sense, comment down below. Let's talk about a very important aspect of building an app. You built an app, okay? You want to put it out there, but you want to put guardrails on it, okay? You don't just want anybody to use, especially in this day and age of AI tools where you are talking to different AI services, right? All these API calls use tokens, and they will charge you. Especially Hedra's API is insane. It takes up so much credit. So you got to put guardrails on it, so that when people use your application, they pay you, so you can then pay your API services. So let's talk about the strategies I used and what I did to implement a monetization strategy into this application. I started off with a subscription model. And before I did that, I researched the subscription model versus the token-based model. Ideally, I wanted to implement both so that to give people flexibility. The subscription model has its advantages. If you want to retain people monthly basis that pay you on a monthly basis to use your application, the subscription model is a good way to lock them down. But then again, people are restricted and they don't want to pay monthly. They want to leave. So that is where you bring a little bit of flexibility by allowing people to buy tokens A lot of AI apps nowadays allow both. They allow you to have a monthly subscription, and then when you run out of tokens on the monthly subscriptions, you can buy additional tokens so you can keep using the application. So that is what I wanted to implement, and I implemented this using Lemon Squeezy. Now within character form, which is this form right here, that allows you to generate content. Okay, so we make this request to the API content generator submit form, and that API is right here, content generator submit form. And now before we do anything, we are checking for tokens for generation. So we are basically checking to see if the user has tokens, so they can purchase tokens through Lemon Squeezy. That is gonna basically take their payments. They can pay through PayPal. They can pay with their credit card. Once that has been registered and successfully, payment has been successfully taken, it generates tokens depending on what they buy. If they bought the $10 token, it gives them 12 tokens, right? So over here, when you generate a video, every time you generate a video, you have to check tokens before generation. So that is what this function does. And if I follow this function right here, basically checking Supabase to make sure we are logged in again. We create an API client. We select balance from Supabase just to check the balance of the user before we do anything. Let me just show you Supabase migration just to show you the token system. So we have this table of token packages. So we have this table created that basically has a token amount, price, currency, Lemon Squeezy variant ID is active or not, or created that and updated that. We also have this table called token balance, and we also added a constraint here to only be bound to the user ID, right? Token transactions. This table is to track all token activities. We have a token purchases table just to track purchases. So basically when you purchase tokens and we successfully store the data in Lemon Squeezy, the response we get back is where we store what we store here. This is for pending checkouts to track in progress purchases. And the next steps are just row level security, just to make sure the appropriate users have the ability to create, to update token balances, all of the different tables that we created. So let's go back to the check tokens for generation. So over here, what we are doing is, and we have this utility function right here, get user token balance, that basically checks the database balance table just to retrieve the balance they currently have within the table. So that is what this is basically doing. So it checks the balance, takes the balance and returns it, and then also calculates has enough tokens. So it takes the balance tokens per video, which we store within our which is a constant right here, which is 3 tokens per video. So we check that against the balance to make sure it has enough tokens. We also send back the tokens required, which is tokens per video. So that is essentially what that is doing. This is doing right here. So token check, we get back that data that we just seen here. Just returned data on line 34. If tokens check that has enough tokens, if they do not have enough tokens, we return back a response telling them insufficient tokens and redirect them back to the tokens dashboard /tokens/purchase for them to purchase more tokens. So that's essentially what this is doing. All right. I'll go ahead and show you how the purchase of tokens is happening. And this is happening through Lemon Squeezy. So once you go to purchase tokens page, which is right here, if I go to dashboard and I go to, right now I have 6 tokens left. If I go to buy more, I can select how many tokens I want to buy, right? I can buy $10, 12 tokens, or $40, 50 tokens, $70, 100 tokens, and $300, 500 tokens. So once I hit purchase tokens, it's going to take me through to Lemon Squeezy's API. And that is what handles everything that we need to basically purchase tokens. And what handles that is this right here, lemonsqueezy.ts in our left file. We have defined the Lemon Squeezy base URL, which is this one right here. This function, we create a checkout ID with a random UUID. We grab the API key we set up in our env file. We also grab the store ID that we get back from setting up Lemon Squeezy. So we need these two important information to successfully make a checkout. So to get your API keys, come here, my account, okay? And right here at the top, you see API. If you click it, it will take you to this page, okay, where you can click on this plus button and you should be able to create your API keys, okay? The next thing is store. You would also need store. So if you come here to store products, okay, if you already set up new product, okay, by clicking new product and setting that up, okay, you would need to grab your variant ID. So this is where you can come and then copy the variant ID. So, and we create a success URL. And basically what this does is, after being able to go through the Lemon Squeezy flow and purchase tokens, I'll show you in a bit right here. If I click purchase tokens, this would redirect me to Lemon Squeezy. This is where you're able to essentially add your credit card information and hit purchase. And once you hit purchase, it will redirect you back onto this URL, which is the success URL. So here we are making a fetch request with the Lemon Squeezy API URL to the checkout. So this is important. So once you hit purchase, it comes to this URL, lemonsqueezy.com/checkout. So that is the endpoint we are hitting. We are making a post request and basically sending this data over to Lemon Squeezy, so it knows what store data, and we are setting the type to checkout, and we're providing it with checkout data with the authenticated user's email, their ID, and then the checkout ID, and then we also passing the store ID as well, and passing the variant ID as well. So the variant ID right here, when we call this endpoint, we are passing the variant ID. So if I trace this to API endpoint calling this, okay, which is API tokens checkout routes, that is what is being called when we basically hit this button, purchase tokens. It calls this function, but before it does that, we are getting the token details from the Supabase. We are getting the token package details from Supabase first, right? And what we need from there is the package data.lemon squeezy variant ID, which is what we are passing on to this function. So we get a variant ID here, and that is what we essentially pass along to this URL. If you observe in the success URL, we are appending the variant ID as well. We get a response back from making the API call to Lemon Squeezy. And if it's not response, that okay, we throw an error, right? But if everything is successful, right, we extract the response.json, assign it to the data variable, right? And then we get the checkout URL from the data variable, right? And that is what essentially we are returning, checkout URL and the checkout ID. Yeah. That is essentially what we are returning back to this URL. So we get a checkout ID. This stores the checkout ID in our Supabase and switches the status to pending, right? And we eventually send the checkout URL back in the response to the form that was calling Lemon Squeezy. So that is essentially how Lemon Squeezy is set up in our application. Hopefully that makes sense. All right, this is how I redesigned my dashboard. Okay, I went over to lovable.com and basically asked it to redesign my dashboard by giving it some basic information about my application, and then it gave me this beautiful dashboard. And then after that, I exported it to GitHub and downloaded it. It will come as a zip file, and then unzip it and go to my code editor and reference it from WinServe and basically copy the path and tell it to redesign my dashboard based off of this workspace, and then provide it with the path to it. And it did a fantastic job. Not a straight shot at first, as you are going to see in a second, but This was the dashboard before, and this is what it looked like after. And I had to go back and forth with a few iterations to get it exactly how I wanted it. As you can see, it did a great job eventually. So yeah. So I realized content just wasn't doing it. Okay, it didn't describe the business good enough. So I went over to business name generator and just filled out information about my application, and it gave me some suggestions. Okay, so I landed at just hit publish. But whilst I was looking for the domain name and Namecheap, I realized, oh shoot, someone might be using it. So let me Google it, and yes, of course, some schmuck was already using that. Just hit publish. Okay, so I realized, oh shoot, I needed a new name, so I settled on gotta share this. Okay, and gotta share this, that site. But then I was ready to hit publish and realized, oh, the Google and Facebook logins were not working, so I needed to fix that. So I went over to Supabase authentication sign-in providers and hit Google, and I needed the client ID and secret. So go over to Google Cloud Console, and over there, make sure you logged in and hit new, create new project, fill in your project information. In this case, gotta share this, and then create. And once you do that, go over to APIs and services, and then click on OAuth consent screen, and then hit get started and go through the application flow. Okay, enter your app information. Make sure you, for audience, hit external and enter your contact information and hit create. And that should create your application. And then go back to APIs and services, credentials, and you want to hit credentials at the top, and then OAuth client ID. And for the drop down, hit web application and enter your application name. In my case, gotta share this. Gotta share this, just gotta share this. And you need authorization redirect. So go back to Supabase, copy the callback URL, come over here and paste it and create. And once that is done, you will be given those credentials. Just come over and add them to Supabase and hit save. And for Facebook, go over to Facebook for developers and log in with your Facebook account and hit get started and fill out the application and hit create app after you fill out that application and enter your app details. And in this screen, select authentication and request using Facebook login, and select your portfolio using your Facebook login, and then go over the dashboard, and within the menu at the bottom, hit settings and then basic, and voila, you should have access to all of your Facebook client ID and secret. Enter those in Supabase and make sure you enable Facebook and then save. And for getting my domain to Vercel, go over to your application on Vercel, hit settings and domain, and enter your domain from Namecheap. Okay, enter add domain, and then make sure you follow the instructions to add the A record, okay, and the C name. Enter all of those from Vercel, and you should be good to go to publish. So at the end of this all, what are some technical lessons here that you can take home? Number one, storage strategy matters, and I'm glad I took the time to make that decision in the beginning. Don't wait until your application is out there, is established, and then you start running into storage issues. I'm glad I went with AWS, S3, even though initially it was difficult to set up at first. No matter what, documentation is king. I ran into this issue last week when I was trying to integrate Hedra. So usually when you're trying to integrate a very complex system, it's probably best to read the documentation first. But I know developers, we do not want to read documentation. Look, I'm in that boat as well sometimes. I don't want to read the documentation. But using these AI tools, you just get to a point where you have to remind yourself that you would save so much time just going through the documentation and at least understand what is going on before you ask AI to do the work, because AI is going to just use all documentation, make up stuff. Then again, some documentations are just not clear. I also came to a realization that feature branches is very important. All of my life experiences, I've used feature branches before and I know the purpose of it, but today just reminded me again why feature branches are so important, especially when you're integrating a huge feature into your application. You don't want to be developing it in your main branch. That is very dangerous, because when things go wrong, how to revert back is very, very difficult unless you have been committing all of your work. But sometimes you're so deep in that you forget to commit. That is where you want to branch away from your working main branch into a feature branch, especially if you're trying to integrate a major feature. Branch away from it so that when things go wrong, you can always come back to your main branch. If the feature branch doesn't work out, you can always abandon it. That is a hard lesson I had to learn. And that is it, guys. If you enjoyed this video, please, it takes a lot of effort to make these videos, so please hit the subscribe button. It's free to do that. And if you're into this type of content as well, then hit the notification bell so you'll be reminded every time I upload a video. Till the next time, it's peace.